Hello, and welcome to 5 Minutes With, a podcast by Geoscientist magazine. My name is Marissa Lowe, and today I'm joined by Hannah Bird from the University of Birmingham. Thanks so much for joining, Hannah. So, can you tell us what you're currently working on?
Currently, my PhD research is focused on deep sea sediments taken from the southwest coast of Australia. So it's the Mental Basin. And from those, I've extracted fish teeth and shark scales, which we call denticles. Both of these together are collectively known as ichthyoliths, and they're used by paleontologists to discern the paleoenvironmental context of the ocean from millions of years ago. So, for example, for me, I'm looking at the early Cenozoic, which has two key, we call them hypothermal events. So they're short-lived periods of intense warming. There's the Paleocene-Eocene thermal maximum, which was 56 million years ago, and the early Eocene climatic optimum. And from those, I'm looking at the ichthyoliths to reconstruct the productivity, the ecological diversity, and the evolutionary patterns of fish and sharks at that time. So this period of time is really important because it's analogous to modern climate change and where we're headed in the future. This is also really important because a lot of the population relies upon fish for a protein source and as part of the overall ecological diversity of the oceans. So knowing what happened to them in the past in response to intense warming is important for us to be able to analyse uncertainty in the predictions of how they'll be affected in the future.
You talked about these teeth and scales as your samples. Were you collecting those yourself? And what do you do with them when you bring them back to the lab?
So the samples were collected from deep sea ocean drilling projects a number of years ago. And I received the samples as just like bulk material. So I had hundreds of these bags. I had to select which ones to use. And then from those, go through the processing of them in the lab. That processing then allows me to pick the teeth from them. And from those, I then analyze what the morphogroups are, etc. So what they look like. So you can have straight teeth, you can have curved teeth, you can have teeth with serrations on or blades on the side. So all of these indicate different aspects of how the fish were using them in life, what their feeding mechanisms were, perhaps what kind of depth of the ocean they were living in, depending on what they were eating. So they can actually tell you quite a lot, even though they're really, really tiny. You can only see them underneath a microscope.
Where are you at with your research at the moment? What is a typical day for you?
So I'm looking at 250,000 year time intervals. And each of these samples are then processed by acidifying them to dissolve the carbonates. And then you wash them to get as small a residue as possible. But that residue is still quite large for me. So I then use a really, really expensive heavy liquid to separate this out. And all it basically does, if you have a little vial, it brings the sediment that you don't need to the top and gives you all of the ichthyoliths at the very bottom. So it's a really tiny amount of material that you actually need to pick through under a microscope. And saying that, it still takes a couple of hours to do each of these samples under the microscope, and you pick out the teeth and the denticles. And from those, I pop them on a slide, I image them with specialist software, and then from that, I use a database created by one of my supervisors, Dr. Elizabeth Seibert, for working out the morphogroups, as I've previously mentioned. And then from that, you can't work out the teeth to particular species, but you can sort of discern the ecologies of the teeth.
So, what's your favourite thing about your research?
So actually is picking the teeth and denticles, even though it's a really long and laborious process, and you definitely get a lot of neck ache from doing it for hours. It's really interesting just to see the different types of teeth, because when you're looking at the slide, it literally looks like specks of dust. And then when you look under the microscope, and it's just a fascinating world that you wouldn't be able to tell without a microscope. With these also denticles in there, which are particularly rare in comparison to the teeth. So when I found my first one, I was very sad and did a happy dance because they were very rare. But it's just really interesting to also see the background material. So there's some really pretty, intricately detailed radiolarians in the background of my material. Also, on a personal level, I use that time to listen to podcasts whilst I'm picking. So podcasts such as this one. So it's a great way for me to multitask whilst I'm picking.
So, what advice would you give to someone hoping to get involved in research, particularly in paleontology?
So as cliche as it sounds, I would probably say you need to make sure that you're passionate about your subject, because if you're committing to it for 3 to 4 years, there will come a point where you do lose some momentum and think, goodness me, there's still X amount of time left. Also consider when you have that amount of time, it will go very quickly. So make sure you kind of keep up the pace in your first and second years to get your data collection done, just so that you're not rushing at the end, but also it allows you enough time to produce manuscripts if that is one of your goals. Along that similar vein, to plan your time really effectively, because you can either sort of go to two extremes of you lose momentum or you work 15-hour days. And I have been guilty of both, as have many PhD researchers. So make sure that you plan your time effectively and get a work-life balance so that you enjoy the PhD along the way.
Thank you so much, Hannah, and all the best with the rest of your PhD.
Thank you very much, Marissa.